Hello student, today we will discuss about the third method of finding the initial basic feasible solution for the transportation problem. The third method is Vogel's approximation method, which is also known as penalty method. So we are going to discuss a simple problem through which we will study how to use Vogel approximation method for finding initial basic feasible solution. So the example that we have here is, consider the following transportation problem involving 3 resources and 4 destinations. The cell entries represent the cost of transportation per unit. As you can see in the given matrix below, here there are destinations and the sources. We have 3 sources 1, 2, 3 and 4 destinations 1, 2, 3, 4. And the values which are written in the cell, these are the cost of transportation per unit. And the rim values, here it is showing the total supply of first source, total supply of second source and third source, and these are showing the total demand of each of the destination. Now the question is, obtain the initial basic feasible solution using Vogel's approximation method, which is in short we write as VM or penalty method. So now we will start to solve this problem. So for that, here I have a solved example and I will tell you how I have done this. So in Vogel approximation method, the first step is that you have to find the penalties. So how we find penalties? For finding penalty in each row and each column, we have to find the penalty. For finding the penalty in the rows, you have what you will do. First of all, you will see the minimum value and the next minimum value. So in the first row, the minimum value is 1 and the next minimum value is 3. So 1, if you subtract 1 from 3, what you get? 2. So here we have written penalty, and what will the penalty we get in the first row, that is 2. Next, in moving to the second row, in this the minimum value is 2 and the next minimum is 5. So 5 minus 2, that comes out to be 3. Now in third row, minimum value is 2 and the next minimum is 3. So 3 minus 2, we get the penalty 1. Similarly, we will do for each column. So in the first column, the minimum value is 2 and the next minimum is 3. So 3 minus 2, we get the penalty as 1. In next, 3 minus 1, penalty is 2. 5 minus 3, penalty is 2 and 4 minus 2, penalty is 2. So now what we will do, we will see that which is penalty is maximum. So the penalty 3, which is against the second row, that is maximum. So we will select the second row. In second row, we will see that which cell is having the minimum cost. So minimum cost is here at rupees 2. So you have to find how much allocation we can make in this cell. So here the total demand was 250 and the supply was 450, out of which 250 is a smaller one. So we can allocate 250 units at this cell. Now when 250 unit has been allocated, so if you subtract 250 from 250, you get 0, and here 400, so we subtract 250, we get 150. Next, what we will do, we will delete this column because its demand has been already fulfilled. Now you will find out the revised penalty with the remaining 3 columns and 3 rows. So here the minimum value is 1 and the next minimum 4. So 4 minus 1, the penalty we get is 3. Here 6 minus 5, penalty 1, and so on. You will again find the penalty, and in the columns also we will calculate the penalties, and here I get all the penalties as 2. So again we will look for the highest penalty. What is the highest penalty? So this 3 is the highest penalty. So now first row will be selected, and from this first row you will see that which is the minimum cost. So minimum cost is here at ₹1. So what is the maximum allocation that we can make? Here we have 350 units and here 300. So from 300 and 350, if we compare, 300 is a smaller one. So we will make the allocation of 300 units, and the supply of the first source is completed. So you get 0, and here is still you have 50 units remaining in the demand. Now again, since the supply has been already consumed, so you will delete this column also, row also, sorry. So now the remaining matrix is only these 3 columns and these 2 rows. So here again revised penalty. So for this row the penalty comes out 1, and in the columns we have the penalties as 6 minus 3, 3, 5 minus 3, 2, and 9 minus 2, 7. So now the highest penalty is this 7, and here the minimum cost is 2. So in this cell how much allocation you can make? 200, and the 500 was initial demand. So you can make an allocation of 200 units over here. So this becomes 0, and 500 we subtract 200. So here we still have 300 units of demand. So now since this column's demand has been fulfilled, so you will also delete this column. Now out of these 4, again you have to find the penalties. The penalties here 6 minus 3, 3, and 5 minus 3, 2, and in row what we get? 1, and 3 minus 3, so 0. The maximum value is 3, so you will select this column, and in this column the lowest cost is 3, and here how much units we can allocate? 50 units, because here it is 300, so minimum is 50. So you will make the allocation of 50 unit in this cell. Now the remaining is, so this has also now become 0, it's also become 0. So you can delete this column also, and out of these 2 now you will make the allocations. So here you have not fulfilled any demand, so 400 is maximum, and here we have 250. So you can make a total allocation of 250 units over here, and the remaining 150 that we may allocate here. So in this way our matrix is completed. Now you have to find the total cost. So total cost is 1 into 300, then 2 into 250, 5 into 150, 3 into 150, 3 into 250, and 2 into 200. So it comes out to be ₹2,850. So this is how we find the initial basic feasible solution using Vogel approximation method.